All right, good day, Breckenridge Buckaroos. This is Mr. B here with Algebra 1 lesson of the day. Today we're doing topic 3-7, which is theoretical versus experimental probability. So if you recall, yesterday we did just probability in general, where we found a probability. Today we're going to kind of expand that a little bit and learn what theoretical and experimental probability are. And those that 7th grade math here in Breckenridge, I know for sure you did theoretical and experimental probability in 7th grade with either myself or the wonderful Mrs. Mayo. So theoretical probability is what is expected. Okay, is what is expected to happen in an experiment. Okay, is expected to happen in an experiment. Experimental probability is what actually happened in an experiment. It's based on the collection data. So just kind of like in science, you have theories, but then to prove your theory, you have to experiment. But then your experimental data could lead to something else. So this is what this is. Theoretical probability is what's supposed to happen, and experimental probability is what actually happened. They could be different things. Sometimes they're the same, sometimes they're different. So Jim tossed a coin 35 times. He recorded whether the coin landed on heads or tails. Use the results in the table to find each experimental probability. So this was his experiment. He flipped the coin 35 times and he recorded his data as such. So what was the probability that he landed and got heads? So it's 20 out of 35, which simplifies to each divided 4 over 7. So 4/7. Probability of getting tails is 15 over 35, which simplifies to 3/7. So what is the theoretical probability of landing on heads? Well, in theory, when you flip a coin, it should be a probability of 1/2. The theoretical probability of landing on tails, once again, should be 1/2. That, in theory, that should be what happens. Number 5, what is the difference between the experimental probability of landing on heads and the theoretical probability of landing on heads? Write the answer as a percent rounded to the nearest whole percent. So up here it was 4/7. Okay, so between the experimental probability of landing on heads, so that means we're going to put the experimental probability first. So you're going to have 4/7 minus, that comes from question number 1, minus the theoretical probability, which is 1/2. And when you work those out, you're going to get about 71 thousandths, which rounded to the nearest whole percent should be about 7%. Okay, and that's going to be negative answer. What is the difference between the experimental probability of landing on tails? All right, so in theory, remember the experimental probability was 3/7 minus the theoretical probability, which is 1/2. Gives you a decimal of about decimal 0.71, it says, which rounded to the nearest whole percent is 7%. Okay, once again, that should be negative. Okay, that should be negative. All right, then this should be a positive, not negative. Mr. B needs to wake up. A nap sure does sound good, but none of you are ever that way. Those of you who are watching me right now at 12 o'clock probably are tired, wishing I would just hurry up and stop rambling. So next example on the back. Mrs. Smith has a bag that contains 6 red Lifesavers, 5 yellow Lifesavers, 8 orange Lifesavers, and 9 white Lifesavers. She has another bag that contains 3 Butterfingers, 8 Snickers, and 4 Hershey bars. If you take a piece of candy from each bag without looking, find the following probabilities. So there is a total of 28 Lifesavers, okay, based on the data it gives us. There are 3, 6, 9, 13 candy bars, okay? 13 candy bars. So that maybe should help us. So the probability of getting a yellow Lifesaver is 5 over 28. And since we're doing compound probability, which means we're doing more than one event at a time, we got to multiply. Probability of getting a Snickers is 6 over 13. And when you multiply those on your calculator and reduce it, you should get 15 over 182. Next up, number 8, probability of getting a red or orange Lifesaver. Well, how many are red? 6 plus orange is 8, so that's 14. 14 over 28 is 1/2. Sometimes I like to go ahead and reduce beforehand if it's real easy. There are 4 Hershey bars, so 4 out of 13. And when you multiply that together, you get 4 over 26, which reduces to 2/13. All right, go ahead and pause it. See if you can't do number 9. Okay, see if you can't figure out the solution to number 9. We want the probability of not a white Lifesaver and a Butterfinger. All right, so the probability of not getting a white Lifesaver means you add all the others. You add your 5 yellow, your 8 orange, and your 6 red together, okay? So with that being said, you should have 19 over 28 times. There are 3 Butterfingers out of 13, so you multiply that together and reduce if possible. And I do believe that's going to be 57 over 364. So 57 over 364. All right, so the next example, okay, we're going to talk about David rolling a number cube. We're going to be finding the theoretical probability. So this is what he actually got. So this is our experimental. Okay, so we're going to be looking for the theoretical. So we're not really going to be looking at this data right here just yet. Okay, so don't let that table there confuse you. So what's the probability of rolling a number cube or a die and getting a 4? Well, how many 4s on a number cube? 1 out of 6 possibilities. Okay, what's the probability of getting an odd number if you roll a die? Well, let's see, there's 1, there's 3, and there's 5. So 3 out of 6, which is 1/2. The probability of getting a 2 or 5, so there's a 1, 2, there's 1, 5, so 2 out of 6, which simplifies to 1/3. And probability of getting a factor of 3, there is only one factor of 3. No, that's not necessarily true according to my key, but there's 2 factors of 3. 1's a factor of 3, and 3's a factor of 3, so it's 2 out of 6, which is also 1/3. Okay. So now we're going to, on the 14, we are going to kind of now be using this table right here. Okay. So now we're going to get to that table. See if I can scroll things down here. What is the difference between the experimental probability of rolling a 2 or 5 and the theoretical probability of rolling a 2 or 5? Write the answer as a percent rounded to the nearest whole number. So let's look over here. Since it lists experimental probability first, we got to find it. So there's 1, 2, 3, 4, 5. So 5 out of how many total rows? 20. Minus the theoretical probability of 1/3. And go ahead and take that to a decimal because we got to change that to a percent. So you get negative 83 hundredths roughly. And as that as a rounded to the nearest whole percent, you should have negative 8%. Okay, so you should have negative 8% there whenever you get your answer. Okay? All right, so your question for today, make sure you go answer it in the classroom part of Google Classroom, but your question is, what is the big difference between theoretical and experimental? In other words, basically tell me what each of them are. What is theoretical probability? What is experimental probability? Thank you very much for your attention, and we'll see you later.